Well, hello again. Welcome back. We're ready for day 2, section 4. This is going to be a fun one, guys. This is one of my favorite lessons all year long. The number e, yes, e is a number, just like pi is a number, and the function e to the x. So to introduce this, we're actually going to evaluate 1 plus 1 over n to the n power for the following values of n, for n equal 10, say. So 1 plus 1 over 10 to the 10th power. And guess what you get? You get about 2.594. You can type these into your calculator, check me. Do it for 100, so it's 1 plus 1 over 100 to the 100th power. You get about 2.705. Do it for 1,000. 1 plus 1 over 1,000 to the 1,000th power. You get about 2.717. Do it for 10,000. You get about 2.718. So there was a larger difference here than there is here. Very small difference now. Do it for 100,000. Guess what you get? You get about 2.718. Virtually no difference. What's happening here? As n gets super big numbers, this number ends up being the same each time. What's it end up being? Oh, about 2.718. That, my friends, is a special number. You remember how pi is about 3.14? Guess what? E is about 2.718. It is. Isn't that awesome? So this is what we're going to say. What happens as this expression, remember this is the same expression that we had in the last slide. What happens as n gets super big? In math, in calculus, we say as it approaches infinity. I'm terrible at making the infinity symbols. Another way to write it, I guess there you go. You can write it like that. As n gets really big, as it approaches some huge, ridiculous number, infinity, this is what we say. Well, we say it has a limit. Remember how it kept getting to 2.718, 2.718, 2.718, 2.7? It never goes above 2.718. We call that a limit. We say, nope, it's limited to 2.718. Can't get higher. This is how we write it. We say the limit. It's a little bit of calculus for you guys. I hope you're ready. It's a preview of what's to come next year in calculus. We say the limit as n gets really big, as it approaches infinity, of that expression, the expression was 1 plus 1 over n to the nth power. Of that, we say that limit, as n gets really big, it's about 2.718. And like I said, that is the number e. That's the number e. Let me write that out for you. The limit, write this out, guys. The limit of 1 plus 1 over n to the nth power as n approaches infinity. That's how we read that. I would read that to yourself 4 or 5 times right now and then look back at this expression. This is it written in algebra. This is it written in words. Is E, which is about 2.718. It's just a lot like pi, which is about 3.14159. Okay. Here's what it looks like in terms of a picture. Like if you were to think about this as a graph. So, like if I give you this graph, here's a function. What's the limit? This is some function f of x. What's the limit of f of x as x approaches infinity? In other words, as x goes to the right, as you go to the right, what is f of x becoming? It's getting closer and closer and closer to what? Well, to the x-axis. In other words, it's getting closer and closer to 0. What's the limit of f of x as x approaches 0? In other words, now, as you go back to the left, as x gets closer and closer and closer to 0, to the y-axis, what's f of x doing? Well, it's skyrocketing. It's going straight up. And is it ever going to stop going up? No, so we call that limit infinity. Infinity. Limits are tough to get at first. They're actually super simple. And once you finally get your head wrapped around limits, you're like, oh my goodness, why did I struggle with that? It's so easy. But it's kind of tough because it's a new notation and it's all kind of read kind of funny. And you see that infinity symbol. But it's really not that bad. Okay, we're going to use what we've already learned about the number e to come up with a formula here. I think you're going to think that this is kind of cool. All right, this is what I want you to do. Use the formula you've already worked with and compound the interest. But we're not just going to, in this first one, we're going to do it quarterly. Quarterly. All right, so we're going to take $1 and do it at 12% per year. And we're only going to do it for 1 year. That's all we're going to do, 1 year. All right, so original amount, 1. That's the A initial. 1 plus the rate, 0.12, divided by how many times? 4 times, quarterly. How many times overall? Well, 4 times number of years. Only 1 year, though. So you punch that in. You get about $1 and 0.12. Sorry, I wrote that wrong. 1255. That's about $1.13. About $1.13. Okay? Now I want you to do the same thing, but I want you to compound it monthly. So now instead of n being 4, n is 12. Okay. So $1, how much you started with, times 1 plus 0.12 divided by 12 to the, not 4, it's 12 times 1 power, because it's only 1 year. And guess what? You get more money. This is how much you get this time. You get $1 and 0.1268. Oh my goodness. So you still have a grand total of $1.13, but technically speaking, you got a little bit more money. But now, instead of n being 4 and n being 12, we're going to do this. N is k. Whoa. Whoa. All right, so what would the formula look like? It would look like this. It'd be 1 times 1 plus the interest rate, 12%, over k to the k power. Now I'm just going to put k instead of k times 1. Okay? Now, this is going to seem kind of weird. It's going to seem really weird. All right? But we're actually going to do this problem in such a way that we kind of work backwards. So, watch me now. Follow me closely. This is a little mini proof. We're going to take this k, and we're going to rewrite 0.12 over k. We're going to rewrite the whole thing as 1 over k over 0.12. Now think about that. When you divide by a fraction, you're really multiplying by its reciprocal. So we're going to rewrite this as 1 times 1 plus 1 over k over 0.12. And you say, what? Just bear with me. Just bear with me. This is going to be kind of cool. Okay, now I want you to take this k and do something even crazier. Instead of putting k, I want you to put this. I want you to put k over 0.12, but raise it to the 0.12 power. Are those not the same thing? Don't the 0.12s just kind of technically cancel out? Well, sure they do. But just stay with me. So check this out. I'm not going to put the 1 anymore. That's kind of silly. Brackets, 1 plus 1 over k over 0.12 to the k, instead of k, what I'm going to put k over 0.12, but then on the outside I'm going to put 1.12. So I've changed the way that it looks, but have I changed the value of the expression at all? No, I haven't. I haven't changed anything as far as the value of the expression. Now, what I'm going to do, and this is going to be awesome, I'm going to let K over 0.12 equal N. Equal N. I see a K over 0.12 right here and right here. Awesome. I love proofs. So this really says 1 plus 1 over N to the nth power. Does that look familiar? Does that look familiar? Wait a minute. On the last slide, Mr. Williams, we said that 1 plus 1 over N to the nth ended up being just some number. Remember what special number it ended up being? Not pi, but e. Folks. Oh, wait a minute. There's still a 0.12 out here. This really just says e to the 0.12 power. E to the 0.12 power. This is what you do when you're compounding not quarterly, not monthly, but continuously. You never stop compounding the interest. Well, pull out your handy-dandy calculator and see what you get when you type in e to the 0.12 power. Okay, so there's a button here that says LN. That stands for natural log. And above it, there's an e to the x. You just have to put, and your TI-83s work the same way. You just have to put second ln, then you have e to the, and we're doing e to the 0.12 power. That's how much money you'd have. Oh, yeah. All right, so what was that? It was about $1.1275. So you'd have even more money. But, I mean, technically, come on, Mr. Williams, it's still just $1.13. But imagine what happens when you start with bigger amounts of money instead of just $1. Well, compounding continuously, you get a lot more money. So the point is that if you're compounding continuously, you don't use this original formula. You use a new formula. Here it is. Continuously compounded interest. You take your new amount and you find that by starting with your old amount, P initial, old principal, times E to the rate power times T. Or we could write it, with A's if you're more comfortable. A initial, E to the RT power. All right, so here we go. Invest $100 at 12% interest, compounded continuously for 1 year. 1 year. 1 year. So, okay, I want to know how much I'll have. So I'll put A of T. I started with $100 times E. Since it's compounded continuously, I got to use E. The rate is 0.12 times T. Well, how many years? Oh, just 1 year. So this is really 100 times E to the 0.12 power. So you type that into your calculator, and you get about $112.75. That's how much money you would have. Nice, $112.75. I could use an extra $12.75 for doing absolutely nothing besides letting my money sit in an account. Find the effective yield. Find the effective yield. Take the new 112.75 minus the old $100 divided by the old $100 times 100 to turn it into a percent. And you're going to get 12.75% effective yield. That's how much money you would have. Or, I'm sorry, that's your percent increase. That's another way to say it, is just say percent increase. Okay, now take $55 compounded at 7%, but do so continuously. Okay, well, my new amount after 1 year would be my old amount times E to the rate times T power, which is just 1. Tap her on in, and you get $58.99. That's what you get. Nice. So, find the effective yield. Find your percent increase or decrease. In this case, it's an increase. Take the new amount, 58.99, minus the old amount, 55, divided by 100. No, divided by the old, Mr. Williams. I'm so used to putting 100 there, but it's not 100 in this case. It's divided by the old amount, which is 55, times 100 to turn it into a percent. And that answer is about 7.25% effective yield. There you go. That's it, folks. That's all I got. All right, I think that's all I'm going to show you for these. I think you should be good to go, but you got new fun formulas to work with. I hope you're excited. Have a good one. I'm out.